We need to expand this function in non-negative powers of z, and also we need to discuss its validity for mod z strictly less than 2. So our function is z plus 1 divided by z plus 2 into z plus 3, because we need to discuss its validity for mod z less than 2. Yes, we need the non-negative powers of z in the expansion, and also we need to discuss the validity for mod z less than 2. Okay, first we need to make the partial fractions for this, writing here z plus 2 and here z plus 3. When taking this denominator equal to 0, we hide z plus 2. We have z equal to negative 2 over here. Putting this value over this fraction, we get minus 2 plus 1 minus 1 divided by minus 2 plus 3, that is 1. So it's okay, I'm writing minus 1 only. When taking this denominator equal to 0, we hide z plus 3. We have z equal to negative 3 over here. Now putting the value in this fraction, we get minus 3 plus 1, that is minus 2, and minus 3 plus 2, that is minus 1. So in the denominator we have minus 1, so let's cancel this. We have only plus 2 divided by z plus 3. So this is how we make the partial fractions, the trick to make the partial fractions. Now from this denominator we take 2 common. From this denominator we take 3 common, because we need 1 plus something. When we take 2 common outside, we have 1 plus z divided by 2 in the denominator, right? So we have 1 plus 2 something, that is 1 plus z by 2. We can expand this. Similarly for this, so let's take 2 and 3 common from the denominators. So further, this is equal to, let me write this term first, because of the negative sign. Now let's take 3 common from the denominator. We have 1 divided by z plus 3 plus 1 minus, when taking 2 common from this denominator, we have z by 2 plus 1, right? So this is 2 divided by 3, and taking this to the numerator with the power negative 1 minus 1 divided by 2, again writing this 1 plus z divided by 2 with power negative 1. So when expanding this, we get 1 minus z by 3 plus z by 3 whole square minus z by 3 whole cube up to so on infinity. Then minus 1 divided by 2, expanding this, we have 1 minus z by 2 plus z divided by 2 whole square minus z divided by 3 whole square, z divided by 2 whole cube up to so on infinity. For it is given that we need to discuss its validity for mod z less than 2. So we have to write here with this, for mod z less than 2. Now when expanding this, we must have the condition mod z by 3 should be less than 1. And when expanding this, we must have the condition mod z by 2 should be less than 1. So let's check we are getting this or not. For mod z by 3 less than 1. Okay, as mod z by 3, this is equal to mod z divided by 3. It is given that mod z is strictly less than 2. We need to check the validity for mod z less than 2, right? So it is given that mod z is less than 2. So this is less than 2 divided by 3, and this is further less than 1. So yes, we are getting mod z by 3 less than 1. And also for this condition, we have mod z by 2, and this is equal to mod z divided by 2, and mod z is less than 2, it is given. So this is equal to 1, which means we are getting mod z by 2 strictly less than 1. Yes, both the condition holds. So you must explain these two steps for both the expansions. And then in the next step, I am going to multiply 2 by 3 inside and also minus 1/2 inside. we get 2 by 3 minus 1 by 2. Then second term will be minus 2z divided by 9. And from here we get plus z divided by 4. So this is plus minus 2 divided by 9 plus 1 divided by 4, and I am taking z outside. Similarly, the third term will be 2 divided by 27 minus 1 divided by 8 z square, that's enough, up to infinity. Solving this first term we get it's 1 divided by 6, and the second term will be, when taking the LCM, we get minus 1 divided by 36 into z. And for the third term we are getting here it's minus 11 divided by 216 z square. Please solve this on your own up to infinity. So this is valid for, this expansion is, yes, it is valid for mod z strictly less than 2, because by using this both the conditions are true. So hence this expansion is valid for mod z less than 2. And we also, yes, we are also getting the powers in the non-negative powers of z. Yes, we have got the expansion in the powers of z, the non-negative powers of z. Okay, thank you.